Hello, algebra students. Mr. Lawrence here, and we're doing a little more with lines of best fit. It's going to be a little bit strange because I actually don't know what happened. I had already recorded part of this, 6 or 7 minutes of it, and it just kind of disappeared on me. So, that being said, I'm going to restart this here. I've got some data on weeks of practice for some typing students and the words per minute that they could type. Now, it's important to note this is not the same student, okay? This is a variety of students, and one it was a beginner and could type 21, and one had been practicing quite a long time. Okay, so there's my input-output table. Now, when you make your scatter plot, which you're going to need to be doing, you want to be careful. Make sure you know your input is your independent variable. It's your x variable. Okay, ask yourself which one causes the other. Do you think weeks of practice causes an increase or causes words per minute? Or does words per minute cause the weeks of practice? I think most people would understand that the weeks of practice causes the words per minute. A beginner isn't going to type as fast as they would, say, 5 or 6 weeks after practicing. Or I should say after practicing 5 or 6 weeks. Okay, so the weeks of practice is your x-axis, and the words per minute is your y variable, your dependent variable. All right, so here's my data, and I have the weeks of practice along the x-axis, and my words per minute along the y-axis. And I chose to count by 20s, spacing things out. If you notice, my smallest output is 21, my largest is 100, and I had 6 blocks to work with, and so I really don't waste any of the graph space. Okay, my lowest number is 0, and my points within 21 of that, and my highest one is 100, and my graph is within 20 of that. Okay, the x-axis was simple. There was 10 pieces of data, and I used 10 weeks. So now I plotted my points. Oh, by the way, if you're wondering about like 2.1, 3.1, it means more than 3 weeks. Okay, maybe 3 weeks in a day, maybe 3 weeks in 2 days, something like that. All right, now to do my line of best fit, which I already have drawn here, maybe I'll redraw it for you. I want to make sure I split the data as evenly as possible, but more importantly, I want to follow the trend. And I'm thinking that as I look here, okay, I'm following the trend pretty well. This point here is going to pull the line downward. This one's pulling it up, right? They're kind of counterbalancing each other. These are kind of counterbalancing. Now, one thing I don't like is that I have 1, 2, 3, 4 points above the line, and I have 5 below. However, you know, I really like this line of best fit. It looks pretty good. I guess if I really wanted to, I could go like this, and I could split the data very accurately then. Okay, but that little adjustment I made shouldn't make a whole huge difference. Remember, number 1 is follow the trend. Number 2 is minimize the distance of the points to the line. And number 3 is to split the data as evenly as possible. So I guess technically this would be the best line of best fit I could draw. Okay, I kind of like it if I fudge this here this way, because I have 2 places, namely here and here, where the line is going through points that I know the exact coordinates of. And it's such a small adjustment, I think I'm going to go ahead and go with that. All right, now I'm going to use this data to answer these predictions and try to give an intelligent analysis of what the data is saying. So first of all, let's predict the words per minute after 5 weeks of practice. Now, it's not going by the input-output table, it's going by the data, the line of best fit. So let me get to 5 weeks of practice and go up here, and then I will go horizontally there. Okay. Now I know that if I'm counting by 20s, then halfway here is 50, and it looks like it might be halfway or just a hair under. So halfway would be 55. I'm going to go with 54. About 54 words per minute. Now, it's impossible for me to get too accurate with this chart, so I will make sure the reader knows that it's not an exact answer. So I'll say approximately 54 words per minute or about 54 words per minute. Okay, if your line of best fit is a little bit different, you might come up with a slightly different answer. As long as you have a high quality line of best fit, things are going to work out well for you. All right, I'm not sure what this means. It's supposed to be predict. Sorry about that. Okay. Weeks of practice if someone can type 70 words per minute. So I can use this line here and move it to 70, which would be smack in the middle of 60 and 80. Take it here till it hits the line, and then from there, drop it on down. Okay, and you see it's not quite 7 weeks of practice. So I could answer this question by saying, the person practiced between 6.5 to 7 weeks. Okay, I like that answer in the context of the problem. 6.8 weeks doesn't make much sense to me, even though the data was presented in that way. And I got this data online, something somebody else presented. If I were collecting it, I don't think I would have called it 4.1, 4 1/10, etc., especially since I'm dealing with sevenths. Anyway, now, agree or disagree? The more weeks someone practices, the more words they can type per minute. And I need to stop right there. Andrew, Gotham, you need to listen to this. Dylan, pay attention, buddy. The more weeks someone practices, the more words they can type per minute. Your personal opinion on the matter is not relevant. It's what the data says. Okay? Does it show a positive correlation that as X is increasing, Y is also increasing? Yes, it does show that. Okay? So, I'm going to start off by saying agree. I agree. However, now ask yourself, is it 100% true? If a person has more weeks of practice, does it guarantee that they will type faster? And I would say no. Look at this person here. Okay, they've practiced for a little over 4 weeks, and they can do under 40 words per minute. And this person here at just over 2 weeks is at 40 words per minute. Or this person here is at just over 3 weeks, a whole week behind, and they're doing almost 50. So you see, it's not 100% true. Of course, there are other exceptions in this data. A great one is this one here at 9 weeks. They're only typing 60, but this person here, 2 weeks behind, is close to 100. So I'm going to come down here and say, however, the statement is not 100% true. An exception, I'm not going to list all the exceptions, I'm just going to list one. If I list too many exceptions, it makes it look like, I'm disagreeing when I'm actually agreeing. An exception to the statement can be seen when one person, I don't know what that word is, sorry, person practiced for 9 weeks and types 60 words per minute, but another only practiced 7 weeks and could type close to 100 words per minute. I might include that also there is a limit to the number of words per minute a human can type. And what I mean by that is that, you know, we've got this person at 10 weeks doing 100 words per minute. Does that mean at 20 weeks they're going to do 200 words per minute? And at 30 weeks they're going to do 300 words per minute? I don't know if anybody can go that fast. I mean, you know, 120 words per minute, that's pretty fast typing. So there's going to be some kind of limit. I mean, if there wasn't, a person could go to school for typing for, say, I don't know, a year, 52 weeks, and they'd come out doing thousands of words per minute. And it's usually assumed that when you're doing these words per minute that they're, you know, relatively error-free, you know, minor mistakes at the most. And it's just not possible, at least not today, maybe 100 years from now, who knows. Anyway, all right. Now, couple other things I want to do. I want to find the slope of this line, find the y-intercept, and write an equation. Well, let's see here. Let's see. It looks like I'm going through the point 120. It looks like it's pretty close to 120. My line of best fit, that is. So I'm going to have 20 minus and 1 minus. And then I'm going through 10, 100. So 100, and that'll be 10. And so I'm going to get 80 over 9. It would be negative, but I'll cancel out. And so my slope is 80 ninths. Now it's very close to 9. Very close to 9. You know, I might say very close to 9. And I may just go ahead and use 9 because it'll ask for the approximate slope. Okay, now the y-intercept looks like it might be about 16. And so my equation is y equals, I'm going to use 9x plus 16. Now, this equation can be useful for predicting the words per minute for a number of weeks of study. For example, I said 54. Let's see what the equation comes up with. Well, y equals 9 times 5 weeks of practice plus 16. So then y is going to equal 45 plus 16, which is going to be 61. Okay, the equation must be off by a little bit because when I did the visual, I didn't get 61. Oh, wait a minute, was it 5 weeks? I actually got below 60. So there must be something wrong with my equation. Let me go back and check it. You know, maybe the fact that I used 20 and 100, you know, maybe that's no good. Maybe it's not actually 20. You know, that black point right there, maybe it's only 19. It's going to affect it. Okay, so also one problem is there is a positive correlation, right? But it's not strong, not very strong. And why do I say that? Because the data is not super linear. It's kind of spread all over the place. There's a couple exceptions to things. Hold on one second. If you take a look here, I've got a lot of different lines of best fit. And take a look at this one. Notice how the points are all over the place. The line you use to predict isn't going to be as accurate, okay, for a line like that. But there is some up here. Let me see if I can get a good one. Oh, look at this one. Okay, I don't even know what this data is about. But look at, whoop, sorry. Let me get back. If you can tell, see how the data is very close to being linear? Very close. That is going to allow you to have a more accurate equation when you do your predictions. Okay. All right. I think we've said enough in this video. I am going to sign off and get some rest, and I will talk to you tomorrow. Good night, everybody.